In this concept, we're going to talk about adding and subtracting functions. If we have two functions, f of x and g of x, let them be any two functions, both functions can be added, subtracted, multiplied, and or divided according to the following rules. Now for the sum, for f plus g of x, we just add the full terms of f of x with the full terms, or to the full terms of g of x. Same for difference. We just subtract f of x minus g of x. For taking the product, we multiply, again, the entire function f of x by the entire function g of x. For quotient now, for division, we can divide f of x by g of x, but then g of x will exclude 0 from its solution set. Okay, because again, we can't have a 0 in the denominator, right? It would be unidentified. We cannot divide by 0. Okay, so in this concept, we're going to talk about addition and subtraction first. Let's look at some examples. So given f of x equals 2x minus 3, and given a function g of x equaling 4x plus 9, find f plus g of x and f minus g of x. So f plus g of x is again just the sum of the full function f of x and the full function g of x. So that gives me 2x minus 3, which is this one, plus 4x plus 9. Very simple, very straightforward. Combining like terms, we have 2x and 4x, and then minus 3 and plus 9, and then in the end, by combining like terms, we get 6x plus 6. Okay. For the subtraction, again, we do the full terms of f of x minus the full terms, or all the terms of g of x, which gives us 2x minus 3 minus 4x plus 9. So 2x minus 3 minus 4x minus 9, right? We just distributed the negative sign here. Combining like terms, 2x and minus 4x minus 3 and minus 9, we get this. Okay, now we're going to talk about multiplying and dividing functions. Given f of x equals x plus 9 and g of x equals x minus 9, find f times g of x and f over g of x. Indicate any restrictions in the domain or range. Okay, because again, we said that for division we have to be a little careful in order to avoid division by 0. So f times g of x is simply the multiplication of both functions, which gives us x plus 9 times x minus 9, which is essentially a difference between two squares, right? So we should end up with x squared minus 81, and in fact we do. Okay. For the division, we have f over g of x is just all the terms in f of x divided by all the terms in g of x, which gives us x plus 9 divided by x minus 9, right? So this is the solution, but this solution includes this restriction on the domain. Okay, so 9 is excluded from the domain of f over g of x. Why is that? Because 9 would make the denominator equal to 0, and anything that makes the denominator equal to 0 should be any value making the denominator 0 should be excluded from the solution set. Okay, so this whole thing is the solution. X plus 9 divided by x minus 9, and x is not equal to 9. Now we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, these first two exercises have to do with addition and subtraction, and then the next two have to do with multiplication and division. Okay, so let's work on these ones first. So evaluate f plus g of x and f minus g of x for the following functions. F of x equals 2x plus 1 and g of x equals x minus 1. Okay, so f plus g of x equals 2x plus 1, in parentheses, plus x minus 1, which again we can combine like terms. So 2x plus x is 3x. And plus 1 plus minus 1, so plus 1 minus 1 is just 0. They cancel out. So my solution is 3x. Okay? F minus g of x is equal to 2x plus 1 minus x minus 1, which is equal to 2x minus x, which is just x, plus 1 minus negative 1, so plus 1 is plus 2, so x plus 2. Okay, next exercise, we have, next we have f of x equals 2x squared minus x, and g of x equals 2x plus 5. So f plus g of x equals 2x squared minus x plus 2x plus 5. So 2x squared has no other similar terms, so we just list it as is. Minus x plus 2x is plus x, and then plus 5 is just plus 5. Nothing else like it. Okay? F minus g of x is just the difference, which is 2x squared minus x minus 2x plus 5, which is 2x squared, and then minus x minus 2x is minus 3x, and then minus plus 5, or minus positive 5, is just minus 5. Okay? In the next two exercises, we're going to look at multiplication and division. So f dot g of x for exercise 3 gives us 3x times x plus 4, which is equal to 3x squared, so 3x times x, and then plus 3x times 4 is 12x. Okay? And then f over g of x equals 3x over x plus 4, which has no further simplification, but I have to list that x is not equal to, or x cannot equal to, negative 4. Okay, because if I plug in negative 4 here, I get 0 for the denominator, and that would be illegal. Okay, last exercise, we have f times g of x is equal to x squared plus 2x plus 1 times x plus 1, which gives us, so x squared times x is x cubed plus x squared times 1 is x squared plus 2x times x is 2x squared plus 2x times plus 1 is plus 2x, and then so plus 1 times x is x, and then plus 1 times plus 1 is plus 1. Combining like terms, we have x cubed plus, so x squared plus 2x squared is 3x squared plus 2x plus x plus 3x plus 1. Okay? For the division now, this is multiplication. Okay. For the division, f over g of x equals x squared plus 2x plus 1 divided by x plus 1. But if you look at this trinomial, this can actually be factored out to x plus 1 times x plus 1. Right? It's actually a perfect square of x plus 1. Right? Because if we go back from these two factors back here, right, we end up with x times x is x squared, 1 times 1 is 1, and then plus 1x plus 1x is plus 2x, so this is good. Okay? And then the denominator is still x plus 1. Oops, and it seems I've had a crash.